Freshwater electrocution is probably not really a topical subject for Australia because we don't have a lot of freshwater lakes, but there are some salient points that are applicable. If your boat's moored in freshwater and your protective earth to the shore installation has been damaged, electricity will want to run through the water and try and get back to earth. But because it's freshwater, it doesn't conduct electricity that well. So what will happen is that you'll have a potential between the boat and the shore installation. Now, if someone swims in between that potential between the boat and the shore installation, they become the conductive path. You're at a beach and there's a mooring for boats, berths in that area as well, and they're jumping off the jetty into the water. The kids are having a great time, and they might jump off, and if they get into the path where they can be a conductive source, they'll get electrocuted. The electricity will jump across, conduct through the body, and then jump back across to the earth system on the jetty. So they'll go into spasm. They'll be electrocuted. Mother will jump in, or father will jump in, or a sibling will jump in and try to help the struggling person. They're going to have the same problem. They're going to run into the electrical current, and they're going to be electrocuted as well. The only way you're going to stop the electrocution is to cut the power. What I've read from articles in the US, it's quite a common occurrence. And something that a few articles have been written on about this subject. Strangely enough, ESHORE is probably one of the few products on the market that actually tests the continuity of the circuit of your protective earth prior to allowing you to energise to your boat. Fundamental electrical systems are all the same the world over. They all require that the neutral and earth be bonded to create a reference point. It's the same thing. Europe and Australia run the same voltage systems and frequency. America runs 120 volt and 60 hertz. All that really requires is that different componentry for the different voltage systems are required. Australia and Europe are the same, so that's not an issue. But for America, I've got to allow for the voltage difference being 120 volts. But fundamentally, it works exactly the same. It's a momentary test to from the active to the protective earth, and checks that there is a circuit between the two. And then once that test is done, it locks in the interlock system, puts the breaker to the power to the vessel, and then drops out that test. I'm an Australian accredited marine electrical surveyor. I have got an electrical contractor's license. I also, when I look in these designs, I also look at international requirements, being IEC and electrical rules from the United States to meet the requirements. One of these is the guidelines is ABYC. I'm an accredited surveyor or installer for electrical systems with ABYC. So I have a good knowledge base of what's required, and this has been built over years of going to sea as a marine engineer and an electrician, foreign going.